This is day 3, similar polygon proofs. So we've talked about how to prove triangles similar. There are 3 ways to do that. If you remember, we have side, side, side similarity, meaning all sides are in proportion. We have side, angle, side, with 2 sides in proportion, and the angle is congruent in between those. And then we just have angle, angle, where you have at least 2 angles congruent. Okay? Example 1 here. We always start our proofs with our given, so we'll write that down. Angle AED is congruent to angle ACB. So I'm going to go over here to this picture and just mark those. It was AED, this angle here, is congruent to ACB, this angle here, okay? We want to try and prove 2 triangles are congruent. So one triangle is AED, the little triangle. Okay, we want to prove that triangle, that little triangle, equals ACB, the big triangle. So we want to try and figure out either something related to sides, but we have no sides marked, so I don't have any numbers to show proportions. So the only option in this one is to prove angle, angle. So when you look at these 2 triangles, we have the little triangle inside of this big triangle. We already have one angle congruent, so we're looking to see if any other angles would be congruent in that picture, and there are. We have angle A is congruent to angle A. And when something's congruent to itself, we did this with like sharing a side. If they share an angle, that's also a reflexive property. So now I have enough to say these triangles are similar. AED is similar to triangle ACB. And our reason would be angle, angle similarity. Alright, so if there's no sides given, we can't show proportions, so you're looking for angle, angle. You're looking for 2 congruent angles to prove angle, angle. Alright, let's try this next one. If you want to pause this and try this one on your own, you can tell there's no sides given, so you're probably trying to look for angle, angle again. So maybe try and pause this one. See if you can brainstorm some ideas how you could prove angle, angle. Okay, so we start off with our given. It says ED is parallel to CB. So couple different ways. Technically, we could almost write down 3 angles in this problem and be able to show that, but we only need 2. So in your proof, you need 2 angles. You need 2 angles to prove angle, angle. So some people might see triangle AED, again, is this little triangle, and you're comparing that to the big triangle, which is ACB. So one thing I noticed that you could use is they both have the letter A in them. So I'm going to say angle A is congruent to angle A. Again, the reason I can say that is reflexive. They share that angle. But they don't share any other angles. So you got to look and think, okay, well, what else do I know? Why did they tell us there's parallel lines? We don't have alternate interior angles, because it's not like a diagonal cutting anything, but we do have what's called corresponding angles. So let's say I choose those 2 angles to be corresponding angles. If I would do that, I can't call this angle D. I will call that angle ADE is congruent to angle ABC. And we call those kind of corresponding angles. Some people might not want to use reflexive at all, and you just use corresponding angles twice. That would totally be okay too, because these on this side is also corresponding angles. So you could do AED is congruent to ACB, and just have like a corresponding, and then the triangles are similar because we have two congruent angles. But since we used reflexive on the last one, I thought maybe some of you guys might have recognized that as an option. So these two triangles are similar by angle-angle similarity. Alrighty, let's go to the next one. Now this next one looks really big. It's because this is the only one that actually has some numbers in it. You can guess if there's numbers in it, it's probably not going to be angle-angle. Okay? So, let's see. We have lots and lots of givens here. If you want to write your givens on separate lines or one line, that's fine. Listing everything out that was in the given. Kind of ran over my line there. Let's see, one more. FE equals 24. Okay. So those are all our givens. I'm going to start putting some stuff in the picture just so we can see it. Okay, let's see. We have AB is 12. BC from here to here is 32, and then we have DE is 9. Oh, I guess maybe I'll do a different color for that triangle. We'll do DE is 9, and then FE is 24. If it's easier to split that into two triangles, that would totally be fine too. You could just draw the two separate triangles. One of the things it tells us is AB is perpendicular to BE. So you gotta think, what does perpendicular mean that we need to look for? Perpendicular means we have a 90-degree angle. So I'm gonna draw in a 90-degree angle at AB and BE. And I can also draw in a 90-degree angle at DE and EB. Sorry. So, if we look at this now, you should notice, because those are both 90 degrees, we have a set of congruent angles. I'm going to say angle B is congruent to angle E by definition of perpendicular lines. Okay, they're perpendicular lines, which means they always meet at 90 degrees, so those angles have to be equal. Alright, so here's where all those numbers come into play. We need to show that sides are in proportion in order to say, like, side, 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 or side, angle, side. So we need to set up a proportion. Let's say side AB in the first triangle should be in proportion with side DE. If we plug some numbers in here, 12 over 9 simplifies to 4 over 3. Okay, and what that was called when we set up that is called a ratio. Definition of a ratio. We want to prove these are in proportion, so I have to prove the other side works also. Because proportion means two ratios are equal. So we will look at, let's do the bottom one. BC is going to be perpendicular to, BC is going to match up with, let's look at, I'm trying to find a picture and see. EF. I wrote on my picture, I couldn't see the letters. So BC matches up with EF, so that would be 32 over 24. Those can both be divided by 8. So that would be 4 over 3. Same reason, we set those together as a definition of a ratio. A ratio is a comparison of two sides, so that's a fraction. You'll notice in this case, the two fractions came out to the same thing. So we learned a property that says if two things equal the same thing, those are equal to each other. That property was called transitive property. Hopefully you remember that. We've been using that one a lot. If two things equal, this fraction equals 4/3, that fraction equals 4/3, if they both equal 4/3, then they have to be equal to each other. Alright, so now we have enough information to say that we have two sides are in proportion, and we have an angle that is congruent. So I can say the triangles are similar. And if you remember, we have two sides in the angle, that's called side angle side similarity. So most all your proofs you're going to do with the similarity, it's probably not going to have that much work on it. You're not going to have ones with numbers necessarily. You'll probably just have the ones like example 1 and 2. If you look back at example 1 and 2, where you were just looking for two angles, these are much shorter. Sometimes they give you an angle. Sometimes you might have to know, okay, parallel lines, those are corresponding. Or parallel lines means alternate interior. But you need two angles to prove congruent, so you can say the triangles are similar. The only one you use the side, 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 or side angle side would be if you have numbers in your proof, so that you can set up a proportion. So you have a definition of a ratio, and then transitive property showing that those two things are equal.